Okay, let us discuss the next problem. This is a fairly easy problem. So from 1.1 to 2. So this is from E Irodov. So this is a disk of mass m. So there is a disk and mass of the disk is m. This is given in the problem. Slide with initial 0 velocity. So v is 0, initial velocity is 0. Down an inclined plane, set an angle 60 degrees. So there is an inclined plane. So let me put something like this. So this disk is coming here, inclined plane is here, and this inclined plane has angle alpha, that is 30 degree. This is given in the problem. Now basically this is a problem of work energy theorem. So you assume that disk is a point. So we will assume disk as a point. Having traveled a distance of L along the horizontal plane. So it says a disk of mass m slides with 0 initial velocity down an inclined plane set an angle alpha to the horizontal, having traversed a distance L along the horizontal plane. So this means this disk is going down, and after some time it travels a distance L on the horizontal plane also. So the distance traveled on the horizontal plane is L. So this travels a distance L on the horizontal plane. Now, and then stops. So here the stops. So V is 0. This means I have to apply kinetic energy theorem. Initial velocity is 0, final velocity is 0. So this means change in kinetic energy is 0. I know this thing. Change in kinetic energy is 0. That is delta K is 0. So find the work performed by the friction forces over the whole distance, assuming that friction coefficient K for both inclined as well as horizontal surface. So friction coefficient is K. Here also we have friction. Here also we have friction. So both have friction coefficient K. Now to find out the work done, it's slightly easy. You see, in this region, how we'll find the work done? You find the forces, mg is downside, and then this will have a component. Now mg sine theta will come, so let me draw here. So this is mg is down. Now if you draw perpendicular here, angle between line is equals to angle between perpendicular, so this angle is alpha. Now on this line, this is the perpendicular. On this line, this is the perpendicular, so angle between line is equals to angle between, so this is alpha. So this is mg cos alpha, and this side will have mg sin alpha. Now friction force is, this is coming downside, so friction force will add up, and the value will be mu times n, because this is a sliding friction, k mg cos alpha. So this is the friction force that will act. Now work done when this distance is given. So basically this distance is not given in the problem. What is the distance by which it traversed? Any idea? So this is mass m, length L, coefficient of friction is K, initial velocity is 0. Find the work performed. Now how can we find this height or this length? That is the important point. Now you see, can I use anything to find work performed? Any idea? You have to find this length. How to find this length? Because force I know, force along the plane is, so this plane along down plane, what is the force? This force is nothing but mg sin alpha minus k times mg cos alpha. So this is the force. If I multiply by displacement, I will get. Now in this case, if the motion is happening on horizontal, friction is simply mu times. So friction is again. So if the moving in horizontal, friction force is acting in this direction, and this will be simply k times mg, because normal reaction is equals to mg. So in this case normal reaction is mg. In this case normal reaction is basically mg cos alpha. In the previous case mg cos alpha, and that's why we have taken friction force is kmg cos alpha. Are you getting or not? In this case friction force is simply kmg. Now work performed in this case is work done along horizontal, plane. So along the horizontal plane, what is the work done? So simple. Force is kmg. Force is acting in this way, displacement is happening in this way. So displacement is L. Now cos is 180 degree because force is acting this side and displacement is happening this side. So you have force this side and displacement this side. So there is an angle of 180 degree. So you will have minus kmg L. So this is the work done along the horizontal plane. What is the work done? So to find length of incline, what we can do is, let us say length of incline is L2. So length of incline, let us assume. What I can do is, I know the force is acting along the incline. Basically, I know the acceleration along the incline. So I can find what is the velocity here. And if I know the velocity here, and I know the velocity here, I know the acceleration in this region, I can write 2 times v is equals to v square minus u square. So you see, when it's coming down along the incline, what is the acceleration? Total force down the incline that we have written, mg sin alpha minus kmg cos alpha. So acceleration is divided by mass. This means g sin alpha minus g sin alpha minus, if I divide by mass, so mass will cancel out. So kg cos alpha. Now, so what is the displacement L2? S is equals to v square minus u square is equals to 2s if I apply this formula. So let me write v square, that is the final velocity, minus initial velocity is equals to 2a. Acceleration is g sin alpha minus kg cos alpha. 2as. S is the distance traveled, that is L2. We have assumed. Now this is the velocity. So this is the first part. Now if this is going along this line, horizontal line, this is the initial velocity. Final velocity is 0. So this is final velocity is 0. And acceleration in this case, basically we have deceleration. And deceleration in this case, force is acting in this direction, k times mg. So deceleration is basically minus kmg by m. So this is minus kg. So now I can write again, final velocity v square minus u square is equals to 2s. Final velocity is 0, v square minus u square. U is this. Now this becomes the initial velocity. U square is 2z, and sin alpha minus k cos alpha. K cos alpha into L2. This is a u square is equals to 2a. A is what? V square minus u square is equals to 2as. S is A is minus k times z. So minus k times z into displacement is L. So from here I can find L2 is nothing but minus minus cancels out, z cancels out. So we have k into L. So 2 cancels out, z cancels out. So I minus cancels out. So I will have k times L divided by sin alpha minus k times cos alpha. So this is the L2. Now work done I can easily found. So you see what will happen to the work done. So work done is, total work done is force along the incline into, so work done by the friction, you see I can always find. So W1 plus W2. So work done is nothing but W1 plus W2. Work done along the incline. So what is the force along the incline? So let me see. Along the incline, so when this is coming in incline, down the incline, the force is mg sin alpha minus So this is mz sine alpha minus kmz cos alpha. This is the force into displacement. So what is this displacement? Down displacement we have already found here. So you see that is the L2. L2 is nothing but k times L sine alpha minus k cos alpha. So this is the W1 and plus W2. So what is the W2? W2 is force along the, so this is the force is mz, kmz, friction, both are negative work done. Kmz, displacement is L. So you can see basically we will have what is the coming. So sine alpha minus k cos alpha will cancel out, I think. So sine alpha minus k cos alpha, this cancels out. So we will have mz kl in first case plus mz kl in the second case. So I think I have missed something somewhere. It should be, so let us check. So if sine alpha cancels out, so there should be something I am missing. So let me check where I am missing.